How to rebuild a vintage steam toy, and this is part 4, repairing the flywheel, painting the base and making the bearings. The flywheel has got a crack in one of the spokes. Now there are two ways to repair this flywheel. The best way would be to drill a hole from the edge of the flywheel down into the spoke and insert a metal plug. But because this flywheel is very substantial and the other 3 spokes will carry the weight, plus it's not going to be heavily stressed, what I'm going to do is actually open up the cracked part of the spoke and fill it with JB Weld. I started off by using a needle file, and then I realised that possibly my life expectancy wasn't going to be long enough to complete this part of the job, so I decided to use a diamond burr in my small Minicraft drill, and this made short work of cutting a groove in the flywheel. And as various viewers have pointed out, this is not the correct flywheel for the engine, and yes, I am aware of that, but it's the flywheel that was on the engine that belongs to the customer, and it's of great sentimental value, so I'm going to retain the existing parts. And by the time I've repaired this flywheel and fixed the sand casting blowholes around the outer edge of the flywheel, it will look fine. This is a clip showing the flywheel after I removed the paint. I used a pot of cellulose thinners for this, and it took about an hour to dissolve the paint, and then I just brushed it off with an old toothbrush. Now it's time to get out the JB Weld, and here is the JB Weld on the board. I'm squeezing out equal amounts from the tubes, and now it's a mixing frenzy to make sure that the JB Weld is thoroughly mixed together. After which I apply it to the flywheel, starting with the blowholes around the outer edge, followed by applying a generous amount of JB Weld to the groove that I've carved in the damaged spoke. I'm putting plenty of JB Weld on the joint, and I'll remove the excess tomorrow once the JB Weld has cured. In this clip I'm holding the painted bracket against the engine, and you can see it's starting to look interesting. The next job is to paint the firebox area of the boiler, but before I do that I'm giving it a thorough rub down. I've already rubbed this down, I know, but I'm giving it some more. And then I'm going to wipe it down with panel wipe just to remove any debris from the sanding process. Before I get my spray gun out, well, it's not a spray gun, it's actually an aerosol can, I need to mask off the parts of the boiler that I don't want to paint, namely the brass part. Instead of wrapping masking tape all the way around the boiler, I use a plastic bag for most of it, it's just quicker. I'm using high temperature paint for this job because the firebox part of this boiler will get very hot indeed. And as usual, the first coat is quite thin. But thankfully this stuff dries very quickly, so I can basically rotate the part and keep applying the paint, and I'm not getting any runs whatsoever. When the paint has dried, it will take on more of a satin appearance. With this paint you do not need to use a primer, in fact it's not a good idea. The heat resistant paints bond straight to the metal. So once this is painted, I'm going to put it on the bench at the side of the flywheel, which has to remain there for 24 hours until the JB Weld has cured. So now it's time to go over to the lathe and make the bearings for the engine. Originally this engine didn't have any bearings, it was a steel crankshaft in a steel frame. And over the years it had really worn badly, mainly due to lack of oil I would think, but steel against steel is not really a bearing material. In a previous episode in this series, I drilled out the mounting bracket to take these bearings that I'm going to make. In this clip, using a piece of wet to dry sandpaper, and I think it's 400 grit, just in case you're wondering, and I'm cleaning up the surface of the phosphor bronze that I've just machined. And here I'm using a parting tool to turn the end part of the phosphor bronze to fit into the holes in the red bracket. Here I'm trying it for size, and it's still too big. You can use parting tools for longitudinal cuts like this, provided you take gentle cuts. But it's not recommended if your parting tool has a replaceable carbide tip that will possibly fall out with the side thrust. The diameter is now turned to the right size to fit into the bracket, leaving sufficient room for some Loctite to hold it in place. When using Loctite, if you turn the parts to too close a fit, then the Loctite will be squeezed out and will be ineffective. And as usual, I've centre drilled the work. Now I'm going through with the drill size, which is 1 imperial size less than 3/16, which is the finished diameter I want. And here is the reamer that I'm putting through. The lathe is now in back gear, going a lot slower, and this is a 3/16 reamer which will get a good finish inside the bearing. I'm going to try the shaft in place. This is a 3/16 of an inch diameter stainless steel shaft. It's just the fit I need it to be, a nice bearing fit. And now it's time to part off the first of the bearings. Notice that I use a drill shank in the end of it so that it doesn't drop into the chip tray. I don't clean my chip tray out very often, so the last thing I want to do is ferret about in a chip tray full of brass chippings. And now, in exactly the way that you've just seen, I'm producing the second bearing. And once again, I'm using a small drill shank in the end of the bearing to catch it as it separates from the phosphor bronze bar. This clip shows the two bearings on a piece of stainless steel bar that I'm going to use for the crankshaft. Before I fit the bearings to the bracket, I'm going to drill holes in them using a centre drill to form oil holes. This is not really necessary, but it's just a nice touch to have proper oil holes in the bearings. I coated the ends of the bearings that fit into the bracket with some Loctite, and I used Loctite 603 by the way, not Loctite 542, it needs to be a firm retainer for this job. I put a drop of my oil mixture into each of the bearings and then I fitted the crankshaft, and I'm measuring the distance between the two bearings because I'm going to make a sleeve that goes over the crankshaft, which will just make it look better and make sure that the bearings never drop out of the mounting bracket. And that's it for this episode. Thanks for watching, and I hope you found it useful.